Thank you all. Thank you for listening. My name is Fabio Revuelta, and I'm presenting to you the work entitled The Flipped Classroom for Physics Teaching. This is a joint work with Patricia Ruiz, Mónica Montoya, Iciar de Pablo, and Patricia Almendros, all of us from the Polytechnical University of Madrid. This is the outline of this video presentation. First, we will see an introduction on the flipped classroom. Next, we will briefly describe the context and the kind of activities that we have done. I will also show you some of the results that we get, and we'll sum up with the conclusions of our work. Traditional teaching is based on lectures. There, the teacher explains the different concepts to the students and solves the problems on the blackboard. Afterwards, the students have to do some homework activities to better understand the different concepts that have been explained in the classroom. In the classroom, this process is just the opposite. Lectures are taken at home by the students by, for example, seeing video lessons, and the classroom time is devoted to other kind of activities like teamwork. The flipped classroom has three main advantages. First, it is very flexible, as the students can do their tasks anytime, anywhere. Second, it enhances active learning. And third, there's usually a better use of the classroom time. The flipped classroom last year in the Physics 1 module of the degree in Agro-Environmental Engineering, where we had 46 first-year students. Physics 1 consists on 6 units, and we applied the flipped classroom to study the kinematics of the rigid solid. The experience was conducted over 2 weeks, where the students have to visualize 9 videos and fill out 9 tests. They could also do 2 optional exercises. After this time, there were 2 online sessions with the teacher to clarify the most involved concepts and solve some of the problems. 25 of the students participated at least once in the experience, 13 on average. And regarding the students' assessment, we've seen in all cases a very large dispersion in the results and almost no influence of the visualization and answering times on their marks. The best results are obtained in the test associated with the easiest videos, namely those on what is a rigid solid, or how can it move, or how can translations be composed. First achievement was obtained in video 4 on how rotations can be composed. Then it was surprising that all students got the right answer on how a pair of rotations can be compared. Regarding the results, we have seen almost no influence on the marks obtained in the flipped classroom activities and those obtained in the partial or the final exams. The red points show the marks obtained in the partial exam as a function of those obtained in the question number 1 in the flipped classroom. And as you can see, no regular pattern can be obtained. Moreover, the data has a very large dispersion. This is something that happens in all cases, and for the rest of the questions, this has been shown in the shaded areas. Similar comments apply for the final exam. In both cases, we see that those students that filled out all the activities in the flipped classroom got better marks, but these differences were not statistically significant. We have also analyzed the marks obtained in the partial final exams as a function of those obtained in the exercise for the rigid solid. And unfortunately, we have also seen, once again, no regular pattern. Once again, we see a very large dispersion in the data. The only conclusion that can be inferred from the figures is that a better mark in the rigid solid exercise usually renders a better mark in the exam. We have also analyzed the marks obtained in the previous academic year as a function of those obtained in the rigid solid. And once again, similar comments apply here. Finally, we have also analyzed the students' opinion on the experience. Most of them found it positive. Moreover, they also pointed out that the classroom time was better used, and on average, they spent 5 hours using the flipped classroom. All in all, we have used the flipped classroom in the teaching learning process of kinematics of the rigid solid in Physics 1. The students' achievements have been rather modest, but still, they find the experience useful and positive. Thank you for your attention.